Wow, money, money, money. This looks exciting. Financial maths, all to do about money and interest rates and stuff. So let's get into it. What have I got here for you? This is thought to be some of the original coins back before the birth of Christ, 600 BC, where the Babylonians had metal coins. And I guess that's a head and that's a tail of the two sides of the coin. Then we got on to modern ones, and here we have some $2. How much is there? 2, 4, 6, about $10 or $12 there, mate. Okay, and then, I don't know whether you realised it, the Chinese were the first, about 1000 AD, to have paper money, and now, of course, we've got lots of different currencies having paper money there. Two of these over here, come over here, the dollar, used in Australia and the United States, and then the euro used across Europe, and of course the yen and various other currencies are used around the world. Interesting stuff. And of course, here we are. Let's do some calculations. There's a calculator, very old-fashioned calculator there, because you're trying to work out whether you can buy this car, this little red sports car. Well, you might be able to buy that one, but I don't think you can buy the big one. Just that replica, mate. Anyway, so we're going to do some calculations and have a look here. Credit card. Uh-oh. Danger, danger there, I think. Why? And this is the subject of, or the centre of our discussions here, percentage. And if you borrow money, you're going to be charged a certain percentage extra, so you're going to pay more. So we're going to get into this idea of percentage both in investment, where your money is going to be earning a percentage, and also in loans where you'll be owing extra according to some percentage. Alright, so let's go and have a look at how we do those sorts of calculations. So these screen clippings in this presentation are taken from Pearsons, and here's a bit of revision I want you to do, and I'm going to help you remember some of this. And the first one is converting the following percentages to decimal. Well, what do percentages mean? Well, let's say you've got 12%. What does that mean? 12%. That means, this is from the Latin, per hundred, percentum. So that means 12 in every 100, or 12 hundredths mathematically, or doing it as a decimal, 0.12. So if you want to find 12% of, what can we do? Maybe 150. We want 12% of 150. You can multiply 150 by 12 over 100, or you could simply convert it to a decimal and do that on the calculator. Either way, these are the same, aren't they? These are equivalent. So there are little quick ways of finding percentages by converting to a decimal. So that's what we want to do up here, so that you get up close and personal with percentage in two ways: the 12 out of every 100 and the decimal way. Okay, and then you can use either way to calculate these that I've just done there. I've done an example over on the right there. And then increasing 40 by 100%, alright, by 50%, increasing it by. So you'll have one lot of it plus the extra percent. So if you want to increase something by 12%, you will multiply by 1.12, because you want the original, one lot of that plus 12%. Have you done that before? What about decreasing something? Let's decrease something by a percentage. So you'll have one lot of it minus the percentage. Let's decrease something by 12%. That'll be timesing by 1, take 0.12 this time. So we'll be timesing by a number less than 1, multiplying by 0.88. Have you done that quick way, rather than finding the percentage and adding it on separately? Can you step up to that? That's very handy in mathematics there, rather than work out the percentage and then add it on or take it off. Add it on or take it away from a multiplier of 1. Think about this. This is supposed to be revision, so we might have to come back and have a go at that and revise it later on. We'll just try to see how you measure up for this unit at the outset here with prior knowledge. Okay, so here powers are important in looking at repeated calculations in financial maths. Can you work out these powers? Evaluate, find the value of. May need a calculator for these. Okay, convert the following to a decimal number of years. Okay, just remembering that there are 12 months in a year. 1 year equals 12 months, or 52 weeks, or we generally say 365 days. It's actually 365 and a quarter, because then every 4 years you get an extra day, leap year. Okay, so can you change them each of these times by dividing by the appropriate unit? So 24 months would be 24 over 12 would be 2 years, that sort of thing. Do you remember any of that? Because later on we will want to work with investing money for fractions of a year. We must be able to work with and calculate any time as a fraction of a year. Alright, have a go. Come down here, and I've got the answers here from Pearsons. So mark your work, and this will give you an idea of, is a lot of revision needed in your case? Do you have to go back and check all that out? Alright, let's move on and see the first thing we're actually going to do. That was revision, and here it is here. Central to all of this is percentages. Okay, let's have a look at the sorts of things you might want to do. You might want to save up to buy a house, or you might be investing money in superannuation, or you might be investing in the stock market or shares, or you might be wanting to save up with my favourite car here, this sports car. I want that. I'm going to have to save a lot of money for that. And there's only one trouble with this. Can anyone see what's wrong with this sports car? It's too small for a start. But look at the colour. It should be more red. Red goes faster. Anyway, if you're trying to save up for any of these things, you will put money in the bank and it will earn interest at a certain percentage. And we're going to talk a bit later on about what banks do, but they get you to invest. They'll pay you for leaving the money with them, and then they lend it out at a higher interest rate, so they make a profit on that. Alright, that's what we're going to do. Let's go down and do some basic calculations now. Here we are. Just explaining what was going on there. So it's all around percentages. Percentages everywhere. What do banks do? Investors are paid a certain, look at that, smaller percent. The bank takes it in and then assesses whether somebody can pay it back. They lend it out, or a borrower comes in and they lend it out at a higher percentage. The going rate approximately for a savings account is about 2.5% per annum. And if you take out a loan for a house, it's approximately 5.9%. Hey, what happened there? Oh, I think the bank just made 3.4%. Okay, and that's how come they make such money. 3.4%. Of course, they've got to cover overheads, all the people working for them and so on. But if you make 3.4%, that's $3.40 in every $100, isn't it? Per cent means per centum, per 100. So if you've got a $400,000 loan to buy a house, or let's say something easier, $200,000, there will be 2,000 slots of this will be profit, wouldn't it? Every $100 they're going to make $3.40, and so in 200,000 you're going to have 2,000 lots of that. You might check that out and just make sure that's correct there. Okay, that's the idea. That's what banks do. So we'll have a look a bit later on at some of that stuff. Alright, let's do some calculation of percentages instead of just talking about it. We want to buy that car, mate. Okay, so here we are. Here's a formula for calculating what's called simple interest. There's various ways banks calculate interest, and we'll be talking about that. So the amount of interest earned is the principal, the amount you put in, sometimes called the present value, PV, sometimes called that, and then you've got an interest rate and a time. Okay, and the time and the interest rate must be in the same time frame. So if the interest rate is per annum, you've got to put your time in years as well. PA means per annum, every year. So you'll multiply the interest rate by the number of years that you're going to have the money invested. Okay, and then the final amount in the account will be your principal plus the interest you've earned. So the interest is in dollars, the principal is in dollars, the rate here is a rate of interest, so it's a percentage in there, okay, done as over 100 if you like, and then times by time. Okay, that's a simple interest calculation. You're assuming that throughout the whole course of the investment, the principal has stayed the same. So I think we need to discuss that later on. Let's keep in mind here, if the rate's a percentage and you're getting, let's say, 2.5% on your investment, it's 2.5 over 100, or dividing by 100 using the multiplier 0.025, using that decimal multiplier. Okay. Are you ready to go? Let's have a look at some examples. And here's the first one from Pearsons again here. $20,000 is borrowed for 5 years at an interest rate of 9.5%. Simple interest. Okay, so what is the amount of interest charged over the course of a loan? How much extra are you paying? So let's work it out. Principal times rate times time, then put in the numbers, list them down like this. It's $20,000, 9.5%, which is that, or 9.5 over 100, fairly high interest rate, time is 5 years. So you will actually be charged amount of interest $9,500. Okay, so at the end of the loan, what will the amount be? Well, you'll have to pay back the $20,000 plus the interest, principal plus interest, so it will be those two, and it totals to that. It's not a bad idea to do what Pearsons are doing here, list with the letter the values that you know those letters take. Okay, so here Pearsons is saying given values for any three, we can work out the value of the fourth. So we're going to do that. Now, do you think this system is fair? Okay, you'll be paying off the loan as you go each month, won't you? And what can you say? What does the formula suggest? The principal is always $20,000. Is that fair? I'm going to leave that with you. Just remember, you might end up paying all of this, but they don't wait till the end of the loan. They make you pay it monthly. So are you always, through all those years, really owing $20,000? Think about it, come back to talk about that later. Let's go to the next example. Example 2. So here, they've got different things missing in these three situations. So you've got to work out what it is. So $200 interest is paid on an investment after 6 months. So what was the interest rate? So let's list them down. We know the interest, we know the principal. What rate of interest were they charging? Okay, so the time was 6 months. Change it to how much of a year it was, a half a year. So you want $200 interest from $5,000. We don't know what interest rate you're looking for. It's in half a year. So to get R by itself, it's been times by these two numbers, and you get the answer 200. Basic mathematics calculation here for solving equations. If to get R back again, you'll do the opposite, reverse operations, opposite operations in reverse order. Opposite operations in reverse order to recover that original number. So you have to divide by these two. R's been times by it, and 200 is the result. So now if you get the 200 and divide by these two, you'll get what R was. So the rate is 8% per annum. Why is it per annum? Because up here we're working in years now, and because it was we usually express simple interest as per year, per annum. Let's look at another one. $350 interest is paid on investment at 4% for 9 months. So what did you have to invest to get interest of $350 in just 9 months? How much did you have to invest? Okay, so the rate has to be changed, 4% has to be changed to a decimal, and the time, 9 months, has to be changed to a fraction of a year. So then write down the formula, the interest, put that in, the principal we didn't know. Okay, didn't know the principal, and then the rate and the time. So to get P back again, when it was multiplied by these two, we got this answer here. So to find out what P was, let's divide by those. That's 350 divided by 0.04 times 0.075. 0.75. So the amount you would have had to invest was $11,666.67. So that in 9 months of 4%, you would have gotten that interest payment. Okay, let's go down. And writing the answer here is a good idea, not just putting P. P is our mathematical language. We want the actual language within the banking industry, and that's the principal. Okay, in the next one, we give an interest rate, interest amount, a principal and interest rate, and we're trying to find out how long. How long do I have to leave that in the bank to get that interest payment? Okay, so write down the formula again, put in the values for each one. Okay, and then find the one that's missing. It has been times by these two, and 1250 resulted. To get the value of T, we'll get the 1250 and reverse what was done to it. We'll divide, and so it's 8.33, or 8 1/3 years. Okay, and a third of a year, a third of 12 months, 8 years and 4 months. Okay, are you ready to try your hand at this? I hope you're still thinking about whether this method of charging interest over that period is a fair one. Let's go and have a look, and we'll have a discussion about that in the next presentation. Let's have a look down here. Now in Pearsons I've cut their problems down. 1.1 was the interest problems, and they go on into compound interest problems, so I've split it into 2 presentations, one about simple and one about compound interest. So I want you to try most of these now. So there's question 1 down to K. The answers are down below. So you might try most of these or every other one, something like that. And then if we come down, I think we can get them all on. Yep, so that's all the initial. So we're down to K, and then keep going on these others. And end of question 2. So that's all the initial Pearsons simple interest problems, and I suggest you have a go at each of them. Make sure you're getting the answers right down to the nearest cent and correctly. Okay, you ready to have a look at the answers? Let's have a look at the answers. Here we are. Okay, check them out. Make sure, you might have to go back and revise and check, but that's our start. You can see how important percentages are. So we're going to move on and get some power in these calculations. So cheers for now. I'll catch you in the next presentation.